Hello everyone. Today we will be covering a topic from IGCSE Cambridge Chemistry, lesson Periodic Table, topic Noble Gases. What are noble gases and what really makes them so noble? Noble gases are the elements in group 8 or group 0. Group 8, group 0 is the very last group of the periodic table, very last one. People call it group 8 or it is also called group 0. Because it's the very last group, what can you say about the number of electrons in the last energy level of the elements in this group? The number of electrons is 8, or you could say the last energy level of all the elements in this group are completely full. And what is the purpose of all atoms in the entire periodic table? All atoms like to have a complete final shell. This is why atoms remove electrons or gain electrons to make ions, to make their final energy electron level or final energy level completely full, because it's a very stable state to stay at. This is why atoms bond with each other as well. So by bonding, they can either exchange electrons or share electrons and make their final energy level full. So we have a privileged bunch of elements in the periodic table who doesn't have to go through any trouble because they have a naturally full electron shell, last energy shell. Because of this, we call them noble gases. Just like how in the old caste system or back in the days of the kings and queens and all these kingdoms, nobles are the ones who are born rich, who are very wealthy with a lot of land. And just like that, even in the periodic table, the noble gases are the elements who don't have to really go through much trouble, who already has the most favorable condition, which is a full shell of final electrons. This is why they are called noble gases. And because they're nobles, they don't like to mix with the others. Just like back in the day, nobles didn't like to mix with any others. They like to protect their territory and just stay like that. Just like that, noble gases also don't like to mix with other elements. They're already full, right? They already have the best condition they could have. So they don't like to remove electrons or gain any new electrons. They're complete. This is why they are very unreactive. They don't like to react with anyone, not even themselves, not even each other. So they are monoatomic gases, which are very unreactive. Why are they gases then? Because they're already, like I said, they are very unreactive and they have a full electron shell. So even their intermolecular forces are very low. Because of that, they're gases. They don't really have any attraction towards anyone. So their forces are very weak. Therefore, naturally, they are gases. All of their outermost shells have 8 electrons, of course, except helium. Helium has only one shell, and the first shell can only hold 2. So helium has only 2 electrons. And because of this, they are unreactive and do not easily form any molecules at all. Some of the uses of noble gases are especially when you want the environment to be unreactive. For example, helium is used to fill balloons. Now, this is because helium is super light. Helium is naturally a gas and it's very light and not reactive at all. So it's not dangerous and it's very light. So when you fill helium balloons with helium, the balloon floats. Helium is less dense than any other gas in the atmosphere, so the balloon will rise up. Neon is used in neon lights for advertisement signs. So neon light inside the neon light, you would find neon. That's why it's called neon lights, right? And then there's argon and xenon. They're used in filament lamps because if you remember, filament lamps are working because of this filament heating up to the point it illuminates. So when heating, if we have a gas which is very reactive, when the temperature rises up, then that gas would tend to react or burn, right? This is why having an unreactive gas is important inside a filament lamp. So no other reaction with gases would happen, or it won't react with the filament itself. So noble gases, although they're very noble and they don't like to mix with other elements, are very important because they have many applications due to their unreactive nature. Now that we have discussed the theory for this topic, let's have a look at a few past paper questions. No compounds of helium, neon, or argon have ever been found, which means they haven't reacted with any other element to make any compound. Why is that? Let's look through all of these statements. Noble gases have octet configurations. Yes, except helium, everything else has octet configurations, which means there's 8 electrons in the last energy level. And helium also has its maximum number of electrons in the last energy level, which is 2. So technically, yes, this is correct. They have no valence electrons. Valence electrons are the electrons that are ready to bond. And helium, neon, and argon, they don't have any valence electrons because all of the electrons, they're already in a stable configuration, so they don't like to bond. So no valence electrons. That's correct. Noble gases are very unreactive, therefore inert. Right. They're unreactive and inert because they have a stable configuration already. So the answer is all of the above. Let's look at one final question. In group 0, what increases down the group? When you go down the group 0, the size of the atom slightly increases. Why? Because the number of energy levels increases. So, of course, the size of the atom increases, which means the atomic radius increases. So, 3 is definitely correct. As you go down the group, the radius increases because the number of electron shells also increase. And as you go down the group, the relative atomic mass increases by a large proportion actually. So density is mass over volume. Mass increases by a large proportion as you go down the group. Volume also increases a little, but not as much as mass. Volume only increases because the size increases slightly. But the mass increases by a lot because the number of protons and neutrons increase as you go down the group. Because of this, as a total, the density of noble gases, they increase down the group. This is also correct. I mean, if 2 out of the 3 is already correct, then the answer has to be all of the above. But let's see why boiling point increases as well. When the size of the atom increases, when you go down the group, the van der Waals forces or the intermolecular forces also become stronger. This is why boiling point of noble gases increases down the group. So according to all of these, the answer should be answer for all of the above. With that, we have come to the end of the discussion of this topic. Thank you for listening.